So here it has been asked that a card from a pack of 52 cards is lost. From the remaining cards of the pack, 3 cards are drawn at random without replacement and are found to be all spades. Find the probability of the lost card being a spade. So here it is asked to find the probability that the lost card is a spade, the probability that the lost card is a spade, given that mm, all the three cards drawn, all the three cards drawn are spades. All the three cards drawn are also spades. So this we have to find. So here also we have to use the Bayes theorem, actually. Bayes theorem we have to use. So let us define some events. Let us define some events. So let's say the event E1 represents that the lost card is the heart. The lost card is a heart. So we know that there are 4 suits in these 52 playing cards. One is heart, one is spade, and one is diamonds, and the other one is clubs. So there are 4 suits, and each suit has got 13 cards. Each suit has 13 cards. So then suppose we define the event E1 as the lost card is a heart. Then we define the event E2 as the lost card is a spade. And we define the event E3 as the lost card is a diamond. And E4 is the event that the lost card is a club. And let's say we define another event A, which represents the event of drawing 3 spade cards, 3 spade cards from the remaining 51 cards. From the remaining 51 cards. Since why one card has been lost. Okay, so here we need to find the probability that the lost card is a spade, means P of E2 given A, means P of E2 given A, that we have to find. So now here the P of E1 means the probability that the lost card is a heart. That is also equal to the probability that the lost card is a spade. That is also equal to the probability that the lost card is a diamond. That is also equal to the probability that the lost card is a club. And that will be equal to 1 by 4. Since why uh, each suit has got equal chance to be lost. Each suit has equal chance to be lost. Each suit is equally likely to be lost, I can tell. So therefore, here we have to find the probability that all 3 cards are spades, given that the lost card is a heart. Suppose. So all 3 cards are spades. So if the lost card is a heart, then 51 cards are remaining. Then out of them, 3 cards we have to choose by 51 C3 ways. And so 13 hearts are remaining. I mean, since the lost card is a heart, so all the 13 spades are remaining. So that will be 13 C3. So this will be 13 C3 by 51 C3. And similarly, the probability of choosing all 3 spades cards, given that the lost card is a spade. So now 12 spades cards are remaining. So out of them 3 spades we have to choose by 12 C3 ways, and from the remaining 51 we can choose any 3. Then similarly, the probability that all the 3 cards are spades, all the 3 chosen cards are spades, given that the lost card is a diamond, is P of A given E3. So that will be, so if lost card is diamond, then also all the 3 spades will be remaining. So I means all the 13 spades will be remaining. So out of that we have to choose any 3, and then out of the remaining 51 we have to choose any 3. And similarly, the probability of choosing all the 3 spades cards, given that the lost card is a club, so that will be also 13C3 divided by 51C3. So now, therefore, we have to find the probability that the lost card is a spade, given that all the 3 cards drawn are spades. P of E2 given A. So that would be P of E2 given means times P of A given E2 divided by P of E1 times P of A given E1 plus P of E2 times P of A given E2 plus P of E3 times P of A given E3 plus P of E4 times P of A given E4. So that we have to solve and find. So this will be 12. So this will be 1 by 4 times 12 C3 divided by 51 C3 divided by this all would be 1 by 4 times. So now this we can call it as, this will be actually P of A. Means here we are applying the theorem on total probability, theorem of total probability, where this P of A can be written this whole thing. P of A is this full. This full is P of A. Okay. So therefore, the probability that all 3 cards are spades, so this will be P of E1 times P of A given E1 plus P of E2 times P of A given E2 plus P of E3 times P of A given E3 plus P of E4 times P of A given E4. So this will be 1 by 4 into P of A given E1. All these 3 are same: P of A given E1, P of A given E3, and P of A given E4. Only P of A given E2 is different. So this will be 13C3 divided by 51C3 plus this would be 1 by 4 into 12C3 divided by 51C3 plus this would be 1 by 4 into 13C3 divided by 51C3 plus this would be 1 by 4 into 13C3 divided by 51C3. So now therefore the required probability of P of E2 given A, that we have to find actually. So this will be okay, P of E2 given A. So this will be 1 by 4 into 12C3 divided by 51C3 divided by this is this whole thing. So this actually we can write it as 1 by 4 into 51C3 times this 13C3 into 3 plus 12C3. Okay. So this would be also 1 by 4 into 51C3 into this is 3 into 13C3 plus 12C3. So this part would cancel. So this would be 12C3 divided by 3 into 13C3 plus 12C3. So this will be actually 12C3 means it is 12 by 3 into 11 by 2 into 10 by 1 divided by this is 3 into 13 by 3 into 12 by 2 into 11 by 1, plus this is 12 by 3 into 11 by 2 into 10 by 1. So 6 2s are 12, and here also 6 2s are 12, and this is 3 will cancel, and 2 6 are 12. So this is 22 into 10 divided by, this is 13 into 66, plus this is 22 into 10. So this is 220 divided by, or we can take actually 11, we can take, sorry, here actually we can do one thing. We can take 22 as common. So this will be 22 into 10 divided by, this is 22 into 13 into 3. 22 3s are 66, plus this is 10. So 22 and 22 will cancel. Then we will get 10 by 13 is 39 plus 10. So the answer is 10 by 49. So this is the final answer. Thank you.